Time. I'm Chris Henry. I'm an associate professor and water management engineer based out of Stuttgart, Arkansas with the University of Arkansas Division of Ag. I brought with me today Stan Hegwood. Stan's from Newport, from Jackson County, Arkansas. He's one of my guinea pigs to let me try new things. And we've been talking about row rice for a while, and he tried it for the first time this last year. Had a real interesting experience, and so he's going to share that with you. Before we start though, I'm going to go over what I've learned, because I've had a variety. I work a lot with county agents, and we've had a lot of I started out looking at this row rice thing because we didn't really know how much yield loss and water use we had from it. So I've done a lot of work with on-farm trials comparing a row rice to multiple inlet. I'll show you some of that data. And then I also have a 40-acre field at the rice station that I've been really trying to answer some questions about row rice on the irrigation efficiency side, because we don't know. There's this perceived yield drag, and how big that yield drag is. Is it really there? So we did an irrigation survey. I showed this if you were in the opening session, but you know, furrow rice is about 10% of our acres in the region now. There's more furrow irrigated rice than zero grade. So that really surprised us. Again, there's a perceived yield penalty. There's a lot of interest in row rice because there's a tremendous opportunity to save labor. You know, not pulling levees through the field. Think about the time you spend pulling levees. If you don't have to do that anymore, you can start to implement cover crops. Because it's really hard to do. I'll take that. And then I needed to answer this question: well, how much water is it really taking? Is it more? Is it something we should not use because we don't know what the water use is? So, and then are there some opportunities to save water? So that's what I did on the station. So for the on-farm work, about 12 fields, paired fields. We had a control field. This is an older slide. They had multiple inlet in it, and then we had the row rice basically. We had soil sensors in every field. Some farmers used them, some didn't. Some people had kind of their way of doing it, so we just let them. And then usually the new guys who hadn't done it before watched the sensors really close. Gave them an idea where they were. And we basically tried to hold it under 40 centibars generally. Some guys held it, you know, just pretty much under field capacity. And we took soil samples, so we knew where they were at, and so we know on every farm roughly where their thresholds were, how far they went. On row rice, you got to shallow the sensors out, so we've been using 6, 12, 4, 6, 12, and 18. Okay, or 4 and 8. You can do 4 and 8, but you really just watch this kind of the top two sensors, and that's kind of what we use. A lot of times the 12 and 8s don't move. You know, if there's enough water out there, they just don't. The roots aren't pulling that water out. So, but it's good to know you've got water down there. And sometimes you do pull that up. You see some of the charts. So on these charts, the shallow sensors are the orange ones. The green is is 18, and so this is probably a silt loam soil. You can see where the rains are. We just gave them this gauge of 40 centibars, keep it under there, and for the most part they hold it. But sometimes it's hard. It gets, you know, those top two sensors got above 40 centibars sometimes, and we get busy and we're trying to do other things. But what I've always noticed is that you'll get these times. Usually this is when I'm calling them. If we're getting here, I've made a phone call and said, hey, we need to put some water to this rice and go take a look at it and see what's going on. You know, around the flat, there's always a time where it seems like the rice really is using water, and you see it shows up. And every time I've called, yeah, I think either I got behind or it really surprises you how much it's using. And it's usually a short period of time. This is another one, so a little more successful at keeping it closer to saturation. Remember, field capacity is going to be right about here in most of our soil types, and so like I said, there's an extreme. Some people can really hold it, and others will let it drifts. So keep that in mind when we talk about what the thresholds are when you hear about it. Everybody, for the most part, use pipe planter. A few of the sites we use surge valves on, and in general what I found is if you've got a silt loam soil, the surge valve is valuable. If you've got a nice clay soil type and you can back water up a long ways into your field, that surge valve may not help you. But on a silt loam where it seals up, they've been really nice because you put more water down that furrow, your wetted perimeter is bigger, you're more likely to get water across that bed. So it's been a nice tool to have in a silt loam. You know, they put on deeper roots and the rice is shorter. One of the lessons learned was you don't want to make your beds too big. And this is a field, the farmer tried it for the first time, pulled the beds. We didn't have a discussion about how tall the beds needed to be. They pulled them for like they would for soybeans, and we fought it all year. You can't get water across, we couldn't get our herbicide activated, we couldn't get our fertilizer incorporated, and so that is that can really hurt you, and you'll see it on the water use because we just had to dump a lot of water to it just to try to overcome it. He had tailwater recovery systems, and it didn't really cost him anything but the energy to do that, but that's a lesson learned. You got to keep really shallow beds. The bed height and bed aspect ratio is really important in row rice.
I don't think you wouldn't be able to get the water down the middle if it wasn't high. And we run into that a lot.
Well, I'll tell you, there is a variety of experience with the bed height. The smaller the bed seems to work better. Just enough of a furrow. Just enough of a furrow. So that's what that's what we would see. That's hard to this is probably after your gate for 3 days still.
We run a John Deere coal mulcher across ours, and it flattens it, and it also rounds it a little bit, so that drill can get more rows and not minimize the middle effect.
I take a 2x4, stick it under the tire of the bedder, and that's how I set the height on the bedder, and that's what we've done. That's how I've learned from the neighbors.
We're planting on this cotton type dirt is that we get so much rain in March, April, that it washes the bed away. We got a problem getting water down there.
Right. Well, if you keep it in a bed rotation where you're not turning the beds up, I think the beds will stay intact better. If you see the striping, I've been trying to eliminate this, where you see the beds in the rows. This is our on-farm data. So this was from 16. In 16, we saw no difference in yields. We're approaching significance on water use. These were 8 fields. Take that high water use out, where we had those beds that were too tall. We were seeing a potential slight water savings, change in water or less water use. About a 4% yield drag, 8 bushel an acre difference in yield. So, it's all over the place. There's no consistent result on whether there is a yield drag. Some guys had better yields with their furrow rice. This is putting 17 and 18 data together. We're basically seeing now that there's a little bit of yield difference, about 5%, 10 bushel an acre, and no difference in water use. So we're concluding right now that multiple inlet rice and row rice are pretty comparable in water use. And that's not what we thought originally. We thought probably be a lot higher. And everybody sends me pictures all the time of water coming off of furrow fields. But if you end block and manage your water well, you can keep it right there in line with Miriam. That's what we're seeing so far. My colleagues have done a little bit of work on the profitability, and they're seeing the profitability kind of all over the place. But some of these furrow rice fields are pretty profitable. You look at your net income, and it's because I think you're eliminating the machinery passes, and we're not really seeing the high herbicide costs. Their spraying seems about the same as the conventional fields. A little bit more fertilizer. A lot of them will put a little ammonium sulfate in the first shot. We need more data on this. Anybody interested in doing paired comparisons in Arkansas? I'll get you meters and measure the water use if you give us the yield, and put sensors in your field. On the experiment station, what's the potential? This is a field I developed. We actually recover the water and return it in the field with a small pump and return system. It allows us to keep water on the field the whole time during the season. This is how we plan it, kind of what the beds look like when we do it. We've planted a lot of varieties in the last couple of years, and we find the hybrids do better than the conventionals. But remember that that I'm doing this for irrigation, and so this stuff is planted, late. I'm the last rice planted in Arkansas County, so keep that in mind. And it's continuous rice. Okay, so the conventionals don't do as well as the hybrids when we do that. But 753, if you're going to start with row rice, that's the one to use. That's the best. That does really well. And if you're going to go with a conventional, Jupiter comes out on top every time we've done it. And that's not one I expected.
That's one I started with Jupiter.
I like Jupiter.
But I just prefer blast.
I know it's got blast, but it seems to do well. We don't.
That's what I've told people.
I have blast in my row rice. This was 17. 753 again came up on top. I also really like Gemini. I tried it this year. Jupiter for the conventionals. But again, these are all relative. Keep in mind that we're planting late. But for the farmers around the area on 750, the yields are right there, where they're telling me. And that yield monitor, and if you've ever grown row rice, you'll probably see this, that you start out top of the field. Here I had 168 bushels. You get to the middle, it's 213, and you get to the bottom, and it's 223. And that's one of the things we're trying to do, is we want to even that out. And we think it's water or nitrogen is what we think, or a combination of both. So next year we're going to try to do more to try to bridge that gap on the top to bottom.
Are you holding water at the bottom of the field?
This has a very shallow a berm at the bottom. About 100 feet, we can back water up, and then there's a pump at the bottom that returns the water, and we block it. So there's a shallow, and we'll call end blocking is the proper term. It's usually a couple inches at the very bottom. Some people block a lot more, and I think that drags their yield down. I think the trick is to have a very shallow pool. It's kind of an area to catch that tailwater and either return it or keep it there through the season. We did a little nitrogen study on this plot. These are large plots. Each plot's about half an acre. And so we put 75 units in with urea with an inhibitor on it over the whole thing, whole field. And then about 3 weeks later on the variety stuff, we put the second shot of nitrogen, 150 units total. In this study, I wanted to look at different forms of nitrogen, because maybe we got some different options with row rice we can't do in flooded rice, right? So I looked at splitting the urea, which is what we do a lot, all up front. And then we looked at using on the second shot ESN, environmentally safe nitrogen rather than urea, just to see if we could, try to overcome that nitrogen issue. We think we might be coming up short. And then the last treatment, with that second shot, we fertigated. We used UAN, 32% UAN, and we fertigated it with irrigation on those plots to see if we could use that as a source, because that's a potential savings. So you're not going to put a piece of equipment through that field if you can fertigate it. We also used Green Seeker to check to see if we're going to be short. No significant difference. They were all really close. We did see maybe a slight difference in the NDVI between the top and the middle and bottom. The middle and bottom weren't different, but they were different at the very top. So that suggests we might have a nitrogen issue to sort out. This is how we did the fertigation. Because it's a split plot design, we actually use drip tape to put the fertilizer in each furrow for the split plot. But what you would do if you were going to fertigate would put it in your poly pipe, basically just inject it into your poly pipe. That's kind of how we did it. Here's the results. Across the whole study, there wasn't 2 bushels different yield. No significant difference with any of the nitrogen forms. So we're going to look at this a little bit more. And so this kind of opens up a Pandora's box for my colleagues and myself, but if we can use some different forms of nitrogen, we can start to do some different things. It could be kind of interesting. We might be able to shave some more, improve the net profit of our furrow rice. And then cover crops. We had a farmer tried cover crops, and we're seeing some, about 11% of our acres using cover crops, generally wheat. But if we can do this, then, and this is one of the drivers I think behind row rice, is now we can start to do cover crops. There's a lot of interest in cover crops. And I think it'll help our infiltration. We've looked at irrigation efficiency, and what we're finding is generally on this field, we've previously done a study where we looked at the efficiency through the season. We start out really good, and then we can get down in that 40% efficiency range. So 60% of what you're putting on is running off the field. And so that's not going into the profile, and the crop's not using it. On average, we're in that 63 to 69% efficiency on this field, okay, this particular field. We put this tailwater pump in. The small pump at the bottom pumps about 650 gallons a minute. Very shallow berm. It's very low cost. You set the faucet design for 350 to 950 gallons a minute. There's no, the alternative to this, or what people would use today, is a tailwater pit. So if you design a tailwater pit for this field, you're going to give up about 2 acres of ground to dig a pit. Okay? And you put the pit, and you got to put a pump in, and you got to return that water. This, you lose essentially no ground to the pump, and we're getting incredibly good irrigation efficiencies out of it. It's patent pending. If you're looking at improving irrigation efficiency, this is an alternative that's new. We're getting over 90%. Okay, pivots generally are 85%. And I just showed you for irrigation 40 to 60%. Okay, so incredibly good irrigation efficiency. Almost no water leaves this field. It's equivalent, my opinion, or dang close to 0 grade. Basically, we're measuring water on. The water is returned with lay flat pipe, supply tubing, 12-inch, and that's kind of what the pump looks like. That's the research pump, and we have some production units that people can try if they're interested in this, and it's available actually. If you want to do this, we can work out something with you to put one in.
What was the energy use? Because you're
It
running 2 pumps.
It costs. It's 3 horsepower, 2 to 3 horsepower. It costs almost nothing to run. And I ran it the entire month of July.
You saved water, which is good. That's good. It's
Yep.
essential. Did you make any yield from?
I just showed you all the yields.
Okay.
Yeah, and then the yields are comparable to what the farmers.
Well, no,
are
this
doing.
is where you're actually pulling the water back off the tailwater and pulling it back to the top.
Yeah. So
Correct?
you pull drains at the bottom. You bring the water back to the pump. It pumps it back up to the top.
Is that what you're doing on all these yields?
No, just this field. It's the
Okay.
only one like it in the world.
Okay.
How far can that push the water?
Well, it's 1,300 feet,
1,300 feet? Would that-
650 gallons a minute, on 2 to 3 horsepower.
How much ride?
Is that electric well?
210. So it'd be a typical field in the prairie soil.
Electric well?
Yes. We have a reservoir, and the water supplied from the reservoir comes through the bonnet, and then
Is it tied back into the same poly pipe that you're pumping with your
Yep.
existing well up on the
Yeah.
upper end of the?
Yeah, and then there's some other
Could
we
you say
made.
again what kind of that's supply pipe, that's not regular?
Supply, so it's a 6 psi. It's the 20 mil tubing. It's not the 7 mil or 10 mil tubing. Very low pressure. Very low pressure. So with that, I'll let Stan talk. Share with him what his experience was with Furrow. Any other questions while I'm switching over?
Have you done any work with different row spacings or furrow spacings?
Yes. Well, everybody kind of does things differently. These were 30-inch rows. I'd say a lot of people use 30-inch rows, but some people are using wider beds, 38s. I mean, it's all over the place what people do. And that's kind of why we did this study, was to take a crude look at what's working, what are people doing, and then what's a lot
60 gonna be
easier.
too wide.
I'll let Stan answer that.
I got one quick question. So, when I was at Mississippi State, Dr. Golden did a test with some ESN, and it floated real bad.
Mm-hmm. Yeah, we were worried about that too.
Did it not run out the end?
It didn't pile up at the bottom like we thought it might. We watched it that, if it floated away, that it should have shown up in the yield.
Yeah.
We should have been short of nitrogen. And we weren't. We took, the green seeker all over
Yeah.
the place, and we're not finding that. So.
Okay,
We're
man.
back.
These
Okay,
two.
yep.
All right, my name's Stan Hay.